Welcome. We are going to today talk about some applications of law of sines and law of cosines. One of the things we're going to look at is how you can find the area of a triangle without actually knowing the height. And then the other will be just using some law of sines and law of cosines in application problems. And it's just some additional practice with using those two formulas. You know, that you might have been sitting at home on one Friday night, and you're like, I wish I could find the area of a triangle without knowing the actual height. Well, today you're actually going to be in luck. You're going to find out how to do that. And we have two ways of doing so. The first, we'll just call Formula 1 for now, says find the area of a triangle, but here's how we do it. If we know, for instance, we don't know the height, okay? So in our triangle, this dashed line here, we wouldn't know, all right? It's unknown to us. But say we knew some combination of two sides and an angle. So in this case, say we know side B, side C, and angle A. So we know two sides and an angle in between. This is exactly the opposite of our ambiguous case, right? We have two sides and we know the angle in between those two sides. We can use a formula that says take 1/2 times the product of the two sides times the sine of A. We could also do this if we knew any other combination here. So for instance, let's say we knew side A and side B and angle C. Then we can find the area by finding the product of the two sides that we know plus or times the sine of the angle that's in between. So let's just try one with this. I mean, this is just a matter of understanding and trying a formula. Let's go ahead and look at this example 4. So we have an area of a rectangular, we want to find the area of a triangular garden having two side lengths of 24 feet and 18 feet and an included angle. That just means the angle in between. So if I draw a picture of that, I will have one side of my garden that will have 24 feet as a side length. And I will have one side of my garden that will have 18 feet as a side length. And then the angle in between those two sides is 80 degrees. I want to find the area of that. So what I can do is I can take, because I know, if we look at our formula here, I know two sides and I know the angle in between. My formula will just be to find the area. I will take the product of the two sides that I know, so 1/2 times 24 times 18. And then I'll multiply that by whatever the sine of that angle is. And then at that point, it's just a matter of using your calculator. Okay, and we end up with just an area of approximately 212.7 feet squared. Okay, and that's pretty much it. To find the area of a triangle using this formula, you just need to know two sides and the angle in between those two sides. The second area formula is called the Heron's formula. Sometimes you'll see it written as Hero's formula. Just kind of depends on which book you're looking at. And it's derived from the law of cosines. And if you're curious about how either of these formulas are derived, that's something that we can definitely talk about in class. I just don't want to take up all that time in the video. So Heron's formula says that if you have a triangle, so let's just call our triangle ABC, okay, and we have our sides across from the angles also labeled ABC. And if we know all three sides of the triangle, so that's the key this time, we know the side lengths, okay, so we would have these three things. To find the area, we're going to calculate it by doing this kind of strange looking formula here. And in that formula, A, B, and C just stand for the sides. But then we see this additional piece of information, and it's called S, right? And it shows up 4 times in that formula. S is just found, it's called the semi-perimeter, if you're curious about it. And it just means perimeter. It means half the perimeter. Okay, so when I say find the semi-perimeter, I'm just saying find the perimeter and divide by 2. And then that's what we're going to plug into our area formula. Okay, so it's kind of a strange looking formula, but let's go ahead and practice with it once. So I know I have example 4 written here twice. This is actually example 2. Find the area of a triangle with side lengths 43 meters, 53 meters, and 72 meters. So if you want to draw a picture, we can. Okay, so we'll have 43, 53, and 72. All right, I want to find the area of this triangle. Now, I do not know the measurement of the height. I don't know any of the angle measures, so it would be rather hard to try to find this in a traditional manner. What I can do is I can use my Heron's formula. Now I have to do two things here. So step one, find the semi-perimeter, find S. Okay, so to find the semi-perimeter, we're just going to take our three sides and add them together and then divide that by 2. You should get 84. So my semi-perimeter is 84. Next up, I'm going to actually calculate the area. And I do that by using the formula. So my area formula will be the square root of, and I'm just going to write the whole thing out. It's the semi-perimeter times, and then we take the semi-perimeter and we subtract each of our side lengths. And we find that product, and then we'll take the square root of it. So in this case, I'm going to have 84 times 84 minus, it really doesn't matter what you call A, B, or C. I'll just label them as seen. 84 minus 53, and then 84 minus 72. And then this is just a long calculation that you need to do, okay? You can do this all in one big step if you'd like. I'll go ahead and figure out what the product is underneath the radical. I'm going to get this really long number here, 1281168, and then to solve for the area, I've just got to take the square root of that. Okay, so I'm going to get an approximation again, 1131 point, let's say 89 meters squared. Okay, so these are just a couple of new formulas. There's really nothing too terribly difficult here. We just want to get some practice using the formulas and know when the best situation is to use each one. So if I know all three sides, I definitely want to use Heron's formula. If I know two sides and the angle in between to find the area, I'm going to use that first formula that we talked about. All right, so up until now, we've spent a lot of time studying right triangles, both in and out of our circle, our unit circle. Although right triangles allow us to solve many application problems, it's more common in life to actually find scenarios where the triangle we are looking at isn't a right triangle. So we'll look at a couple of examples here, and we're going to find that because these are not right triangles that we're dealing with, we're probably going to have to use either law of sines or law of cosines, and we're going to have to figure out which one is best for the scenario that we're in. So this is actually example 3. All right, so example 3. 2 radar stations are located 20 miles apart, and they both detect a UFO in between them. The angle of elevation, that's a term from back in geometry, and I'll show you what that looks like on our picture, measured by the first station is 35 degrees, and the angle of elevation measured by the second station is 15 degrees. So what is the altitude or the height of the UFO? Now I've drawn the picture for you. So this would be station 1. This would be station 2. Now when we talk about an angle of elevation, we're just talking about if you look up from the horizontal, that's your angle of elevation. So these are our angles of elevation, 35 and 15 degrees. The distance between the two stations is 20 miles. Our goal is to find this. Okay, so how do we find H? Well, we've got probably some work to do using law of sines, law of cosines to begin with, and then maybe some right triangle work after that. So this is going to take a few steps, all right? Let's just kind of start by filling in what we do know. All right, in our triangles, we actually have 2 right triangles in this figure. We have one here, and then we have one here. Okay, so if I were looking at just the blue right triangle for a minute, okay, what I know is that the angle up near the airplane, or where the UFO is, right here, is going to be 55 degrees. And then I can do the same thing in the red triangle, right? I can find that, and that's going to be 75 degrees, which helps me figure out that the entire angle there is going to be, 130 degrees. So if we look at this angle here, that's 130 degrees, which is helpful because now I actually could use the law of sines. So I'm just kind of going one step at a time, always keeping in mind my ultimate goal is to find the height. But here's the thing. I now have, let's give these names, right? Let's call this A, let's call this B, let's call this C, and then what I'll have here is little a, little c, and little b. At this point, I could find little a or little c pretty easily. I'm going to go ahead and try to find one of them, all right? So let's do this. I know angle B is 130, so I can do sine of angle B, 130, over little b, which I know is 20, equals Let's go ahead and find little a. So I would take sine of 15 over little a. Now I know at this point you should be able to solve that pretty quickly. So go ahead and pause the video here, solve for little a, come back and check your answer. And hopefully you get around 6.76. Once again, double check that you are in the correct mode. You should be in degree mode. So now I have 6.76. So here's what's interesting about this. What if I just took a look at that blue triangle for a minute? Okay, just that blue triangle. Now here's what I know about that blue triangle. I know this is 35 degrees. I know this is 6.76. I know this is 55. I'm trying to find h. Here's the thing, we've got a right triangle, don't we? So we can use regular old right triangle trigonometry as long as we have enough information. And in this particular problem, I have the height that I'm looking for. I'm going to call this C. And then I have two angles that I can choose from. If I were to say, I don't know, pick the angle that's 35 degrees, then when I look at the pieces of the triangle that I know, this would be my opposite side. This would be my hypotenuse. And we know that the opposite side and the hypotenuse are related by sine. So I could say, all right, well then sine of 35 degrees is just going to be h over 6.76. And then I've got a really easy equation that I can actually solve for h. Multiply both sides by 6.76. And then just type that into your calculator. And you should get, we'll say 3.88 miles is an approximation for h. Now, I could have done the same thing with the red triangle. Okay, I could have said, all right, well, look at the red triangle, and I know this is 15. I know this is 75, and I could figure out what c is using law of sines. And then once I know c, I can do the same thing I just did and use regular right triangle trigonometry to figure out what h is. All right, last example here. It's example 4. This time we have a boat leaving port. It's going to travel 10 miles, turn 20 degrees, and travel another 8 miles. How far from port is the boat? So if our port is right here, we're going to call that point P for port. Here's where the boat turned. We'll call that T. And then here's where the boat is. We'll just call that B. So this little angle in here is our 20-degree angle. Now, it's outside the triangle, right? But here's the thing. Just zoom in a little bit here. Even though I know that angle is 20 degrees, I know that when combined with this angle that's inside the triangle, the two of them have to add up to 180. So I can figure out that that angle in the middle of the triangle there is going to be just 160 degrees. Remember your work from geometry. These are a linear pair. They form a line. So 160 degrees and 20 degrees has to add up to 180, which it does. Well, now I've got this triangle where I know two of the sides and an angle in between. So because I don't know an angle and a side that are across from each other, I can't use law of sines. This is going to have to be one where I use law of cosines. And I'll go ahead and label our sides. So 8 miles will be side P. This is side T. That's our distance that we want to find. And then 10 miles is going to be side B. So since we know angle T, all right, I'm going to set this up where I have angle T on one side of my equation. Move this over a little bit. So I'll have angle T with the cosine. On the other side of the equation, I'll have T squared. And then in between, I will use the other two sides. 2 times P times B times the cosine of T. All right, so I'm setting up my law of cosines video. Now, I'm going to plug in what I know. Okay, so I do not know T. That's something I would have to find. And that's what I'm looking for. I'm looking for that total distance traveled. Little p is 8. Little b is 10. Let me go ahead and put those in where they belong. And then we know that T, capital T, angle T is 160 degrees. And then what's great about this is that we know everything on the right side. So this is one where we can just plug everything into the calculator and we don't have to worry about order of operations at all. So if you do that before you take the square root of both sides, you're going to get t squared is 314, we'll say 0.35082. All right, and then we take the square root of both sides, and you're going to get t is approximately 17.7. So looking at our picture, that means that our boat is about 17.7 miles from port. So today, again, the lesson was just trying to practice a little bit with law of cosines and sines, use them in some application problems, look at the area formulas that are derived from those two, law of sines and law of cosines formula. And again, just get some practice with using the formulas again. So you'll get some more of this in class on the next time I see you. If you have any questions, be sure to leave them at the end of the video. All right, see you soon.